Roll No 23 VV1A1225. Quick sort. It is an efficient sorting algorithm that works by selecting a pivot element from an array and rearranging the other elements so that those smaller than the pivot come before it, and those larger come after. This process is repeated for the sub-arrays on either side of the pivot until the entire array is sorted. It's known for being fast and requiring less memory since it sorts the array in place, but in the worst case, it can be slower if the pivot choice is poor. Despite this, it is commonly used for large datasets due to its average time complexity of O(n) log n. Key concepts. Divide and conquer. The algorithm splits the array, or list, into smaller sub-arrays, sorts those sub-arrays, and then combines the results. Pivot element. Quick sort uses a pivot element to partition the array into two smaller sub-arrays, one where all elements are smaller than the pivot and one where all elements are greater. The pivot is placed in its correct position, and the process is repeated for the two sub-arrays. Steps of quick sort. Choose a pivot element from the array. This can be done in various ways, such as selecting the first element, last element, or a random element. Partition the array into two sub-arrays, one with elements smaller than the pivot and one with elements greater than the pivot. Recursively apply quick sort to the two sub-arrays. This is done until the sub-arrays are of size 1, which means they are already sorted. The sorted sub-arrays are then combined, but since each sub-array is already sorted, no further merging is required. Pros. Very efficient for large datasets. In-place sorting, which means it doesn't require additional memory for another array. Often faster in practice than other O(n) log n algorithms like merge sort, despite having the same average time complexity. Cons. Not stable. Equal elements might not maintain their relative order. Pseudo code. Function quicksort, ARR, low, high. If low at high. Pivot index equals partition, ARR, low, high. Quicksort, ARR, low, pivot index, 1. Quicksort, ARR, pivot index plus 1, high. Function partition, ARR, low, high. Pivot equals ARR, high. I equals low, 1. For j equals low to high, 1. If ARR, j, equals pivot. I equals I plus 1. Swap ARR, I, and ARR, j. Swap ARR, I plus 1, and ARR, high. Return I plus 1. Explanation of above image. To sort the given array using quicksort, we begin by selecting 14